Greetings, and welcome to a tutorial on recursion, which is why the screen looks the way that it does. So recursion is a very powerful technique in programming, but it can take a little bit to wrap your mind around it. The general idea behind recursion is that a function calls itself in order to solve a problem. The nonsense that we have on screen right now is a very good visual representation of what recursion is. I am recording my screen, and recording my screen, and recording my screen, so on and so forth, until it finally just sort of collapses into a point and can't be recorded anymore. This is a recursive display of my screen while I'm trying to do the video. So let's take a look at a programming example. Like, how do we actually program something to be recursive? And a good test subject for that is the Fibonacci sequence. So as a quick reminder, because we have dealt with these before, the Fibonacci sequence is 1, 1, 2, 3, 5, 8, so on and so forth. In other words, the nth number in the sequence, f of n, is always the sum of the previous two values, f of n minus 1 and f of n minus 2. With two exceptions, the first and second numbers in the sequence are both 1. So again, if I want to find the third number in the sequence, or f of 3, that would be f of 3 equals f of 2, 3 minus 1, and f of 1, 3 minus 2. Of course, f of 1 and f of 2 are both 1, so that would become 1 plus 1, which is 2, which, yay, that does in fact give us the correct value. So on and so forth. If I wanted to find the fifth number in the sequence, that would be f of 3 plus f of 4. 2 plus 3 is 5. Of course, I could compose that down even further. F of 3 is f of 2 plus f of 1, so on and so forth. So how can we represent this in a program? Well, coming down here, we have our Fibonacci sequence function. When writing a recursive function, it is absolutely critical that you include a stop condition, something that will end the recursion. So in this particular case, given the definition of a Fibonacci sequence, f of 1 and f of 2 is the perfect stop condition. F of 1 is equal to 1, and f of 2 is equal to 1. So by using those as my stop condition, anytime that I say f of 1 or f of 2, I am going to not do the recursion. I'm just going to return 1. Also, there's a bug here that could cause this function to infinitely recurse on itself until either the program crashes, if you're lucky, or your entire computer crashes, if you're not. Think about that while we're talking about this. We'll come back to that point. Now, of course, if the value isn't 1 or 2, I need to figure out what f of n minus 1 and n minus 2 are. Now, a quick note about what's going on down here. If I wasn't doing a lecture on this line here, line 26, is how I would actually write this. I would say return fib of a value minus 1 plus fib of a value minus 2. However, that makes it difficult to demonstrate what's going on with the function calls, which is why I have broken it down into a equals fib of value minus 1 and b equals fib of value minus 2, and then returning a plus b. It just makes it a little bit easier to demonstrate what's going on with the recursion. And to prove this works, if I do fib of 6, which should be 8, I indeed get 8. If I do fib of 5, I get 5 as expected. Now, before we move on to do some step through so we can see in more detail what's going on with this, have you spotted the mistake yet? What happens if you pass in a negative value? If I pass in, or even just 0, anything less than 1, but if I pass in 0, is 0 equal to 1 or equal to 2? No. So therefore, I'm going to come down here, and I'm going to do fib of 0 minus 1 and fib of 0 minus 2. Is negative 1 equal to 1 or 2? No. Call negative 2 or negative 3. Is negative 2. You get the idea, right? It will never stop. If you pass in a negative value here, it will endlessly recurse. Where do you put this anti-check on this? I'm not going to in this particular case, but you could put this anti-check inside the function or put this anti-check outside the function to make sure that you can't pass in a negative value. Do be aware that if you pass in a negative value here, it will lock up the program at the best case. The worst case scenario, you could crash your computer doing this, so please don't. All right, let's see what's going on with the actual function call. So I am going to drop in a breakpoint on line 22, and then I'm going to run this. Now, as we can see for our variables, currently value is 2, and I have 1, 2, 3, 4 functions open. That is something important to consider when dealing with recursive functions. You can have a lot of functions open very quickly, and that can be rather inefficient. So you got to be careful with that. We'll take a look as to how bad this can get in a moment. But for now, we did f of 5, right? So that means we had to do f of 3 and f of 4, which means the f of 3 has to do f of 1 and f of 2. And currently we're on the f of 2, right? So if I step out, so I'm going to use step return, as it says in Eclipse. So I'm going to do an F7. We can see that we are right here. And I'm going to use step into F5. So we've already evaluated that function, so we're not going to step in. A is now equal to 1. And value is currently 3, so we're going to step in. So F5. Value is now 1. We're going to return 1. Now B is equal to 1, so A is 1, B is 1. Now that's going to return back. So now we're on value of 4, so we're on the f of 4 call. We have finished that. Now we're going to drop in here for another f of 3. And now finally we are on the f of 5. So A is equal to 3. And now we're going to go back down the whole chain. Until finally, we're now back at our original function. And A has been calculated to be 3. B has been calculated to be 5. And so we're going to now print out, oops, didn't mean to step into for that. We don't need to step into print line. And so now we have printed out 5, which of course is correct for f of 5. Now take that breakpoint out because we don't need to continue to have that. Oh, right, that's the to-do note right there. Okay. Ooh, actually, let me put that back in, the breakpoint back in there. Now, what happens if you call it with a large value? What happens if I call Fibonacci of 50? Well, bad things. First of all, a 32-bit signed integer cannot hold the value of the 50th number in the Fibonacci sequence. It's too big. But something even worse is going to happen. Will you take a look at all of those function calls? Mind you, this is just the first round. We're going to have a lot. It's never going to be more than this at once. But we are going to repeatedly have this many function calls open. This is not good performance. Like, I'm going to go ahead and remove the breakpoint here and allow this to continue while I'm talking. This is going to take a moment to evaluate. This is one of the downsides of recursion as a solution. Recursion in programming does allow you to do some very elegant solutions, but as you can see, that took a fair amount of time. There are far faster ways of calculating Fibonacci sequences. That was already quite the amount of time to try to solve. You can only imagine, and I'm not going to hit run on this because I don't want to risk crashing Eclipse, what would happen if you try to find the 500th value in the Fibonacci sequence using recursion. This would be a horrible idea. You would never actually want to do this. Even if you did solve the problem of 32-bit integers obviously not being able to hold this, you would run into other issues. So that is recursion. We have a function. The function is calling itself until it reaches a stop condition, at which point that will cause a chain reaction of the recursion functions solving themselves until you finally get back to the original function call, which will generate the final answer. That is, in general, how recursion is going to work. So your assignment's kind of a lightweight one, because I want to give you a chance to sort of get your mind wrapped around recursion before I hit you with next week's assignment, which is going to be the 8 queens problem. If you want to get a head start and look that up, feel free. It is one of the more interesting recursion problems and actually works really well as a recursive problem. But we're not doing 8 queens, we're doing factorials. So again, as a quick recap, 3 factorial is defined as 3 times 2 times 1, which of course the answer is 6. And so the goal for this program, you're going to prompt the user to enter a number, and then you're going to display the result. So as an example output, you will display enter a number, the user enters in a 4, and then you're going to display 4 factorial is 24. Your only restriction is that you have to solve this recursively, and that means you are strictly forbidden from using for and while loops for any purpose. If you have even a single for loop or a single while loop, you will get a 0 on this assignment. And do not use loops. You must use recursion to solve this. Also, remember to be careful with how high you test your factorials. Factorials very quickly exceed the ability of signed 32-bit integers to hold. So keep your test range sane. I wouldn't go much above 8 factorial in terms of testing your values to make sure that they work. And that's it. Pretty simple assignment. Now, before I wrap up this lecture, a quick note. See, let me switch back to Java mode here. A quick note about switching the primary file. So when you get this project, it will be configured to run the lecture file. Notice if I press F11, it's going to run the lecture.java file. It's also why I have the system.print meep and the system.print main here. You are more than welcome to get rid of this when you do your assignment. This is so you know which file is running. In order to switch the file, you need to right-click on the file and tell it to debug as. So if I want to switch to main, I'm going to right-click on main and say debug as Java application. And now my console output says main, and if I hit F11 or I click on debug main, it's now on main. If I want to switch back to lecture, I have to right-click, debug as Java application, and now I'm back as lecture being the primary file. So pay attention to that. When you're going through and after you've downloaded this, or after you've cloned the assignment, you're working on it, and or like listening to the lecture, you will need to make sure that you right-click on main, tell it debug as Java application, verify that you see main here and not the output from the lecture file. Your assignment must be in main. I will not accept it if you do it inside of lecture.java. Your assignment must be done inside of main.java. And that's it. Good luck with the assignment, and I'll catch you next time for the 8 Queens problem.